right? Make sure
Yeah.
we're not doing. Okay. So like the way to write this is that you have to say point R bisects segment PQ.
It's in the middle.
Yeah, basically it's in the middle. And the reason you know it's a midpoint is because these are equal. Um, the line on top is kind of redundant with this right here. And you maybe you're supposed to say line segment. So they're really picky about the wording in this course.
Mhm.
And that's okay. I mean, that's that is the nature of this thing. So um, there could be more than one midpoint. So we'll see that here in the second example. Um, you can see that X is the midpoint of WY and Y is the midpoint of XZ. So a midpoint means it's right in the middle, and you just have to say as much. You have to say, point X. Actually, I'm sorry. I shouldn't use the word bisects. I should just say, well, I guess they did use the word bisect. Okay. I'm trying to be really careful here because you're not supposed to add or take away words. You're supposed to just use what they give you. So the other way you could sort of say it is what I'm going to do here, which is point X is the midpoint, of WY. And then you can similarly go point Y is the midpoint of XZ. So on your first test or quiz, they typically give you a diagram with some lines, maybe some shapes, and they ask you for things like this, like which of the following is a midpoint, which is a line, which is a line segment, which ones are collinear. So these definitions are important.
Yeah.
It's more of a vocabulary test than anything else. Right now, um, the last one. The last one here, um, you don't really have enough information to say that D is the midpoint of AC, but it sure looks like it, right?
Yeah.
And so there's this initial part of the course is you cannot assume. We all make those jokes about assumptions, um, but in this course, like for the first half, you can't assume things. Like if two things look like they meet at a right angle, you cannot assume that it's a right angle.
You have to
You
show
cannot.
evidence. Yeah.
Now, like in this drawing here, my perception is that they meant they've left out, they either meant to put something here or there's some assumption here that this line connects them and you can prove congruence, which we'll do later in the course. But I believe you're still supposed to say, point D is the midpoint of AC.
Mhm. Yeah.
Okay, but you may want to ask your teacher. You may want to say, hey, look, I was looking at this problem over the weekend, and like if it was purely up to me, I would tell you there's not enough information to say that D is the midpoint. You don't know enough. Like you can't just say, well, it looks like it's in the middle. Um, it's kind of like when you split, you and a friend, you cut something in half. Okay, you have half, the other half. Is it exactly in the middle? Probably not, but
Yeah.
it's close enough. Now, you just cannot assume in this course that that is okay. So for me, I would just, raise my hand and say, hey, I was looking at this problem,
Not
and
assume.
what do you say? Like, is there enough to say, okay, those are for sure that is the midpoint, or no, it's not. All right. Any questions up before we move to 27?
No, no, no.
Okay. So this course is more, if you're a detail-oriented person, you're going to be great at this. Meaning you really like getting into the details, like if when you play sports, you like to check, your gloves or you make sure your hands in the right position. Like
Yeah.
or if you're just a big picture guy, like, hey, we won the game. Like that's going to work against you here. Okay. Draw a plane containing four coplanar points, A, B, C, D, A, B, C, and D, with exactly three collinear points, A, B, D. So the typical planes are drawn like this, but they extend infinitely in all directions. You don't have to draw the arrows, but you have to know that they go in all directions
Okay.
forever. And sometimes like people hold up a sheet of paper in the class. They're also infinitely thin or yeah, they have no thickness to them, which is kind of odd as well. But they extend in all directions. So if you're trying to draw like parallel planes, which this we don't need to in this one, but it would look something like this. You see how like one is kind of underneath the other.
Yeah. Yeah, I do.
Yeah. So I mean, we can do that now. Um, collinear, collinear means they're all on the same line. So you draw a line, and you should use a ruler. I should point that out here. Does your teacher emphasize like how important having a ruler and straight edges in this class?
Not yet. I'm sure she will, but
Yeah, like you're supposed to, right? Like this is not straight. I've got a little curve to it. Like I don't know. Like it depends on what they're emphasizing. And there's a reasonable question to ask, like why should I even care? And I don't have the answer to that. Like no one's going to ask you to draw a straight line in real life. Um, if you're putting lines on the road, you're going to use a machine to do that. Not you, but like we don't ask people to do.
Mhm.
Um, but I don't know. Maybe in this course you will. So just be careful. So you got to put A, B, and D on the line. That's what collinear means. Collinear, another definition. That's another thing you get at the end of the first unit is they give you like a review thing where it's got all these words, collinear, coplanar, and you have to define them and know what they are. So collinear means on the same line. And then the other point is not on the line. So make it really clear that it's not on the line. Like don't try to like make it unclear. Say, okay, it's over here, it's not on the line.
Right. I'm on the line.
So when your teacher grades this, like let's just say this is a test question, they want to see a plane, they want to see a line, and they want to see a point not on the line, and you do have to label all three of them. You could even get into make sure you're using capital letters for them. Um, you have to be consistent.
I see.
Um, what's the next one here? Let me go back to chat.
Is it 29?
29. Okay.
Yep,
So
29.
do you have graph paper?
No, but I can make a little graph.
Yeah,
Here.
it's good to have some. You can throw that in an Amazon order or something.
Yeah.
It's just good to have. It's like uh, all right, so 29, it says draw AB where B has coordinates 2 comma -6. So first thing is when you have a line above it, that means line segment. And that's fixed on both ends. Okay. If
Okay.
it's got arrows, that's a line. It extends infinitely in each direction. So I incorrectly use the word line all the time. When I say line, I typically mean line segment. And most people we make this mistake. We should actually say line segment, but we don't. We say line, meaning line segments. It's one of those weird things in the English language that we probably shouldn't do, but we do anyway. It's kind of like, and forgive this. I mean, it's the only one that comes to mind. When we say drinking, someone's drinking. They're meaning drinking alcohol, but they don't say it. They just say the shorthand. We
Yeah.
say line, and we really mean line segment typically. Like if a line extended infinitely, you know, right? The your first base line, does it extend infinitely?
To the fence. I mean,
The fence, right? I don't know. Does it keep going? That's that, like, right? Home plate.
yeah.
The baseline, does it go forever? Not really, right? We just we really mean line segment. And that's important here. So when you draw B to -6 and you connect A to B, it stops. Like there's no lines, no arrows on each side. So you have to be really careful that you draw the right thing. Like if you extend this,
Mhm.
that's wrong. So geometry is
And-
very specific.
yeah. I
It's
see.
more like a English punctuation class.
So then we're just supposed to point these, or
You're supposed to put the point B in and then connect it with a line segment.
okay. So 2 -6.
And then we'll do the next one here for 30.
All right.
So I'm gonna do this one in red, do 30 in red. Okay, so 0, 0 is at the origin. And that's O, and then M is at 2, 2. Now this right here is called array. Array is fixed at one side. They have to tell you which side it is. It's the first letter. And then it extends infinitely in the other direction. So this time you do need an arrow. You need to say it goes through that point and then it goes forever in that direction. But the first letter is where it starts, and the second letter is what it goes through.
Well, so that's all we have to do for this is
Yeah.
show
Yep.
that it's going the other, like,
You just want to show that. Yeah. And again, like the way, and you should label the points. So that's O, that's M, 2, 2, 0, 0, 0. Um, and your test question will be like they'll give you a drawing like this and they'll say, um, give an example of a ray. And then you'll have to give that one, or give an example of a line segment or something like that.
yeah.
And then 31 here, you can probably figure this one out now pretty easily on your own, but do it together here. I'll do this one in blue. Draw CD through points C and D. So C is -2, 1. Oops, not there. -2, 1. And -2, -3. Okay, so that's C and that's D. And this time, because it's got the arrows on both ends, this is a line. Line, not a line segment. It does extend infinitely in each direction. So, it goes up, goes down. Make sure you show the arrows on the end.
Got it. And nice.
So a couple of things here uh, to point out here, just to kind of extend this a little bit, is let's say I draw this. This is A and this is B. This is correct notation. This is not correct notation.
Oh, because the A has to be before the B?
That's right.
Yeah.
That's right. So, but having said that, there's variations on this that could be okay. So let's just say I draw a line segment this time. I'm sorry, a line, and I draw A, M, and B. Okay. The following are correct. A, M, A, these are correct. So
Mhm.
these start at A and they go through M forever. Start at A, go through B, and go forever to the right. These are okay. The following are also okay, but they are different. BM starts at B and goes to the left forever. BA also starts at B and goes to the left forever.
Do you not have to include though the A part for BM? Because you just read BM, it wouldn't be
So
BM.
there, you just have to pick a point away from the starting point.
Yeah, okay. All right, that makes
Okay,
sense.
but what I'm trying to show you here is that these are different. Like these over here, these go right, and these ones over here go left. Like they're not the same, but they're okay notationally. Like BM goes this way. BA
Right.
goes
Yeah,
to
it
the
goes.
left.
Yeah.
But the other ones go to the right. Like AM goes to the right, AB goes to the right. Like they're not the same, but they're correct. Whereas in the previous problem, the only possibility is AB to the right. BA to left. There's no arrow here.
Yeah. I see. Yeah. Got it.
Right. Let me see if I can find something related to this for us to work on. You'll also get some stuff on angles. Um, so this is these are the definitions here. Let me pop these in. This kind of summarizes everything we've done today. So a point is pictured by a dot. It is named with a capital letter, like that. A line segment is a straight path between 2 points. It's fixed on both ends. It doesn't extend past them. And it can be written as BC or CB. So like you can either go, left to right or right to left. It doesn't matter. Lines, which extend infinitely in both directions, they can also be labeled with two letters, DE or ED, but they go forever in both directions and they have to have the arrow in front. The rays are the exception, okay? It has to be from the starting point, the fixed end, in whichever direction it's going. That's the big
So
difference.
it can go in either way.
It's only FG, only FG.
Oh, I see. Okay.
Like you cannot, it's not GF. That's the big distinction between them.
Gotcha.
Let me look for a few more of these. So does your teacher post future assignments or anything upcoming?
No, I don't have future assignments yet.
Okay. So you could ask, you could say, hey, I want to get ahead. Sometimes they will, a lot of
Yeah.
times they won't. Um, and this isn't really all that useful for like there's no SAT, ACT problems here. These are just so yeah, let me throw some questions up for you to think about here. Uh, right. So it says here, use the diagram to answer the following questions. There are arrows here. They're hard to see. It says, what's another name for this? Now, is this right here? Because I don't want to give it away. Is it this one, this one, this one, or this one? Like which one is this.
Oh, well, the
Which
lines on
is
top, that's a line segment, right?
that is a line segment. So it goes from E to Q. So what's another way to label it?
Uh,
So let's go back here.
it
When it's
can,
a line segment, what's the two ways to label it?
oh, you can go both ways, EQ or
Yeah,
QE.
yeah. So is it which letter is it? Which of the answers is that?
Uh, B,
It is B. Why is A wrong? What is wrong about A?
the line or the arrows.
Right. So it's line versus line segment. Small distinction, but it's like 2-3 defense, 3-2 defense. They're not the same, but they have the same letters in them. Right. So let me grab the diagram one more time. Got another question here we can ask. Okay. So what is another name for? Can you tell me what word goes with this symbol above the letters? If you need me to, I can scroll up.
Wait, I think I'm, is this wait, are you asking for the name or the AD?
Yeah, like I don't want to like I that's so one of the issues in this class. Like I can't
Is
just
this
tell you
a
tell you what
line?
so let's go back and look. The line has arrows on both ends.
Oh, it's array.
It's array. So I have the advantage here of the color coding. Which one does it start at? Which letter?
W.
W. So it starts at W and it goes in the direction of F. So that's what it is. Sometimes it's helpful to color code it here. So we want another one. So it has to start at W.
Okay. So then W, oh, WN, or is that on the line? You can't do that.
You can. Okay.
I still
So because it starts at W and it goes to through N, but it keeps going forever. Are those the same?
yeah,
Yeah,
yeah. If it keeps
absolutely.
on going forever,
Yeah,
yeah.
perfect. Okay. Just looking for some more questions here. All right. Okay, so here is a box and the faces, the faces are considered planes. Okay, so for example, the front face, AEHD, that's considered a plane, the front one. You see that?
Yeah.
Now, it extends infinitely in all directions. Okay, so this from A to E extends infinitely in both directions. So which is correct? This or this?
Well, it goes in both ways, right? So the one on the right, I think, but I'm
So they're actually both correct. It depends on whether you're fixing it, but the line does go on forever. So actually, like AE is kind of the best answer, but they're both kind of correct. Um, So, and let's say we looked at the plane on the left here. So let's say we're looking at A, E, F, B. This also extends infinitely in each direction. So if I'm looking at AB, this is also true because it extends infinitely.
Yeah. And
Okay.
I'm going.
All right. Now, next thing here, that's kind of the build up to be able to answer this question. Okay. Wow, why did that go away? All right. The figure below is a rectangular shipping box. Great. Name two different planes that contain A, B. Okay. So the plane has three letters on it. CDA is this top plane. Okay. CDG is this one on the right. AEB is this front one, and so on. Okay. So take a minute or two here and see if you can come up with the answer here. And it's containing line A, A, B.
I'm between A and D, but I don't.
Okay, so here's what I'm gonna do. I'm gonna help you out here. Here's AB. I'm gonna draw AB.
Yeah, that's A, B.
It is part of the top one,
Mhm.
and it's part of the left the
Okay.
left side. So which are those two planes?
So that eliminates anything with G or H, is what you're trying to say? And like it has to be on that side?
This is the left side.
Like A, B, E, F, those?
Okay, A, B, B, F, you said? Okay, let me try and help you out here. A, B, D, C, A, B, E, F.
Yeah.
So the answer has to contain, like if it's referring to this top plane, it has to have three of the four letters, or three of the four letters. If it's the left plane, it's gonna have three of the four letters. So which of these answers refers to the top and the left?
C, D, A, B, E, F,
Okay, so which one is that?
D,
Which answer is that?
D.
D. Yeah. Okay, good. All right. Now, probably should have had you do this problem first. I was scrambling here to find some more problems here. So a plane is represented by three letters. Okay. So plane RST. Okay. And it's typically in alphabetical order. Typically. Okay. Now, the other thing is, see how there's kind of this letter off to the side here and it's cursive?
Yeah.
You can also use a single letter to refer to a plane. So you could say plane V. This is all like definitions. It's like when you first learn how to like use commas or semicolons or quotation marks when you're learning English, they show you all the variations on it.
Yeah.
And like it's pure memorization. There's no like math here, so to speak. It's not like algebra where you're solving. It's memorizing all this. All right, so let's look at a line here next. All right, so a line. So a line can be represented with two letters like WX.
Right.
Are
Because
there, is there another way that you could represent this line with two letters?
X, Y.
X, Y, good. Anything else you see?
W, X, Y. Can you say it fully or no?
You need two letters, only two letters.
Oh, Y, W,
YW.
W,
Now
Y.
what's missing here is the flip of these, which really isn't different, but you could do that.
Got it.
Okay. Alternatively, you can use the single letter line M. So notice that it's lowercase. Again, I don't make the rules. These are just the rules. So um, a line can be represented by two letters or a lowercase letter. Plain can be represented by three letters or a single uppercase letter. All right, so then there's this sort of classic exam question where they ask you if something is sometimes, always, or never true. And students don't like these. I don't like them either. But these do come up. So we have to know how to tackle them. So it's easiest if it's sometimes true, because that's where you got to find one that worked and then one that doesn't. That's the easiest. Never true means you can never think of an example, but that's sort of limited by your ability to come up with things. So that's harder. And then always true is actually a proof. You're going to do a bunch of proofs in this class in the first semester. So it says, are any two distinct points collinear? So point A, point B. Now, what makes them distinct? What do you think, Mateo? Is it what about the way I've drawn this indicates that they're distinct?
Two different things.
Right, they're not the same.
Yeah.
Okay? So don't draw them on top of each other. They have to be distinct. Now, it just said if you omit that word, it just says any two points are collinear. Well, if they're sitting right on top of each other, that's not distinct. Are these collinear? Are they on the same line?
Yeah, but they're not right on top of each other.
That's right. But they appear to be collinear. So this one is either always true or sometimes true. So can you think of an example where there's 2 points that don't fall on the same line, but they're distinct?
On this line.
Well,
Well,
and then you can draw
yeah.
anything you want. I mean, you can
Uh,
go, C to D, are they collinear?
so something would have to land on the line for it to.
Right.
Okay, then yeah, because any point can go, or like
So this is always true.
always
This
true.
one is always true, and this is a definition. So the ones that are always true are typically definitions. You will be given those there. Now, all it takes is changing one word and then it doesn't work. Okay. So let's look at one that is sometimes true. And this is one we sort of already talked about. Any 3 points determine a plane. So here are 3 points, A, B, and C. does this determine plane? Are they distinct points?
Yeah.
Yes, so this works.
Mhm.
Here are 3 points that are collinear.
Hmm.
This does not work
Yeah, it
because
doesn't.
it could be this plane. It could be the plane that's going this direction. It could be other ones. Okay. This one
Mhm.
does not work. So this is sometimes true.
But
And
not
that's the
always.
challenge. That's right. And that's the challenge in this course. You have to be able to think of a counterexample, which is hard because like how do you know the counterexample until you've been shown it? I don't know. Yeah,
Mhm.
that's not it's not really fair, but that's what the issue is. So if you're the kind of person that thinks of options, you're going to do well in this course. If you're not so good at that, you're going to have to work a little bit to think about, was there another way to represent 3 points?
Right.
I mean, frankly, it could be A, B, C, right? Like
Yeah.
you could do that because it doesn't say distinct. It just says 3 points. Well, they're right on top of each other. So, all right, we're going to go ahead and stop there for today.